Hey guys, today we drift far beyond the familiar glow of stars and spiral arms, into a place most people never think about when they imagine the universe. You are floating gently in the darkness, leaving behind clusters of glittering galaxies, watching their light thin out until it becomes sparse and then almost absent. Around you, the universe feels vast in a new way. Not crowded, not dramatic, but quietly immense. This is the space between things. The part of the cosmos that rarely makes it into posters or documentaries, yet quietly dominates everything. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And as you settle in, you might like to leave a comment telling us where you're listening from tonight and what time it is where you are. Maybe you're lying in bed, maybe you're watching lights pass by outside a window, or maybe you're already halfway to sleep. Wherever you are, let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. You have probably grown up with a very specific picture of the universe. When you think of space, your mind fills with swirling galaxies, glowing nebulae, bright stars scattered like diamonds across a black canvas. It feels full, busy, alive with light, and in a way, that picture isn't wrong, but it is deeply incomplete. Because while galaxies are beautiful and dramatic, they are also rare. They occupy only a tiny fraction of the universe's total volume. The rest, almost all of it, is something else entirely. As you continue drifting, you begin to notice how the distances stretch. The spaces between galaxies grow wider and wider, until entire regions appear almost empty. These are not small gaps. They are not simple holes. They are vast beyond easy comprehension, spanning tens, sometimes hundreds of millions of light years. Regions where the familiar markers of cosmic structure, bright galaxies, dense clusters, are almost entirely missing. These are what cosmologists call cosmic voids. At first, the word void suggests nothingness, an absolute emptiness, a cosmic vacuum where existence itself has been switched off. But that idea, comforting in its simplicity, turns out to be misleading. A void is not a clean absence. It is not a perfect blank. Instead, it is a place where matter is simply scarce, extremely scarce. So scarce that compared to the cosmic average, it feels almost unreal. To understand why these voids matter, you need to gently let go of the idea that the universe is evenly spread out. It isn't. On the largest scales, the cosmos organizes itself into an intricate pattern often called the cosmic web. Galaxies gather along vast filaments, like beads on invisible strings. These filaments intersect at dense nodes where galaxy clusters form, and between those glowing threads lie enormous bubbles, the voids, pushing outward, quietly expanding, shaping the universe by their very emptiness. Right now, as you float here, you are entering one of those bubbles. The light around you fades further. There are no nearby galaxies blazing across the sky. The universe feels calmer here, less crowded, almost shy. This is where the majority of cosmic volume resides, even though most of the universe's light does not. The idea can feel counterintuitive. How can the universe be mostly empty, yet still be described as rich, structured, and dynamic? The answer lies in proportions. Galaxies contain most of the stars, planets, and visible matter we care about, but they are confined to thin strands and sheets. The voids, by contrast, are enormous. They dominate the map simply by being everywhere else. As you move deeper into this region, the silence feels heavier. There are fewer gravitational interactions here, less tugging, less pulling. In denser regions, galaxies constantly influence one another, stretching, colliding, merging over billions of years. Inside a void, those influences are faint. Space itself feels more relaxed, more gently stretched. This is why voids are sometimes described as the universe's quiet rooms, places where the cosmic noise fades, where time seems to pass with fewer interruptions. And yet, these regions are not irrelevant. In fact, they may be essential to understanding how the universe evolved into what you see today. Long ago, in the early universe, matter was distributed almost evenly. Almost, but not perfectly. Tiny fluctuations existed, subtle differences in density that were barely noticeable. Over time, gravity amplified those differences. Slightly denser regions pulled in more matter, becoming filaments and clusters. Slightly emptier regions lost matter as it flowed away toward denser areas. Those regions became voids. So the void you are floating through now is not a failure of structure. It is the result of structure working exactly as physics demands. Matter leaving, space stretching, gravity shaping absence as carefully as it shapes presence. You may begin to sense how misleading our usual cosmic imagery can be. We focus on what shines because light is easy to photograph and beautiful to look at. But light tells only part of the story. The true architecture of the universe is written just as much in darkness, in the vast regions where very little happens, yet everything is influenced. Inside this void, there is no dramatic spectacle, no explosive colors, no swirling storms of gas, just an immense, gentle openness, a reminder that emptiness itself can have form, behavior, and meaning. That the universe is not simply a collection of objects, but a balance between where matter gathers and where it does not. As you continue drifting, let that idea settle slowly. The thought that most of existence unfolds not in crowded brilliance, but in quiet expanses like this one. Places that seem empty at first glance, yet quietly govern the shape, rhythm, and fate of the cosmos. And with that calm understanding, you keep moving forward, deeper into the vast spaces between galaxies, where the universe speaks in whispers rather than light. You continue to drift forward, carried not by momentum, but by curiosity. The darkness around you is no longer unsettling. Instead, it feels deliberate, almost organized, as if this emptiness follows rules of its own. Slowly, a realization settles in. The universe is not random chaos scattered across infinity. It has structure, quiet, patient structure, vast enough that you can only sense it when you step far back and let go of familiar scales. From this distant vantage point, you begin to perceive the universe not as isolated islands of galaxies, but as a single, interconnected whole. Imagine pulling away even farther, until individual stars blur together, until galaxies themselves become faint points of light. What remains is a pattern, subtle, elegant, and immense. This is what scientists describe as the cosmic web. It doesn't look like a web in the everyday sense, of course. There are no neat lines or perfect symmetry. Instead, it resembles something organic, something grown rather than built. Long, thread-like structures stretch across space, each one composed of countless galaxies bound together by gravity. These filaments intersect and overlap, forming dense junctions where galaxy clusters gather. Between them lie enormous cavities, the voids, swelling outward like bubbles and rising foam. You might picture it as a sponge, suspended in darkness. The solid parts are thin, intricate, and luminous. The empty spaces are vast, rounded, and quietly dominant. Or perhaps it feels more like a cosmic honeycomb, where matter traces the walls and edges, leaving hollow cells behind. No matter the analogy, the message is the same. Emptiness is not an accident. It is built into the universe's design. As you float alongside one of these filaments, you sense the difference immediately. Here, gravity is stronger. Space feels slightly tighter, more crowded. Galaxies are closer together, exchanging subtle gravitational nudges over billions of years. Light is more common here, not bright in a blinding way, but frequent enough to give the region texture and depth. Then, just as gradually, the filament fades behind you, and you slide back into openness. This constant alternation, dense thread, vast gap, dense thread again, is the defining rhythm of the cosmic web. It emerged from the earliest moments after the universe began expanding. Tiny variations in matter density, almost insignificant at first, were stretched and sculpted by gravity over unimaginable spans of time. What started as a nearly uniform fog became a grand, three-dimensional network. The voids play a crucial role in this story. As matter flowed toward denser regions, these empty zones expanded. They pushed outward, gently shaping the filaments and walls that surround them. In a sense, voids are not passive spaces left behind. They are active participants. Their expansion helps define the universe's large-scale geometry. From within this void, the cosmic web feels like a distant framework, barely visible but always present. You cannot see its full shape from here, just as you cannot see the outline of a forest when standing between the trees. Yet you can sense its influence. The direction matter has moved. The reason galaxies are where they are, and not elsewhere. What's remarkable is how consistent this pattern is across vast distances. Whether astronomers map nearby galaxies or peer billions of light years into the past, the same web-like structure emerges. Filaments, nodes, voids, repeating on scales so large they defy everyday intuition. The universe, it seems, prefers this architecture. As you linger in the quiet, it becomes clear why voids occupy such a central role. They are not simply gaps between important places. They are the background against which all structure is measured. Without voids, filaments would have no contrast. Without emptiness, density would lose meaning. There is a strange calm in knowing that the universe organizes itself this way. That even on its largest scales, it follows gentle rules rather than violent randomness. Matter drifts, space stretches, patterns emerge slowly, patiently, over billions of years. Nothing rushes, nothing shouts. From here, the cosmic web feels less like a battlefield of gravity and more like a breathing system, expanding in some regions, tightening in others, always seeking balance. And the void you are traveling through is one of its deepest breaths. As you continue onward, the filaments recede further into the distance. The web becomes an idea rather than a visible structure. Soon, even that sense of connection softens, leaving you surrounded once more by the immense stillness of the void itself, a place shaped by everything around it, yet defined by what it lacks. As you drift deeper into this immense quiet, the idea of a void begins to sharpen, not as a poetic metaphor, but as something with boundaries, scale, and definition. This is no longer just empty space you happen to be passing through. It is a distinct region of the universe, recognized, mapped, and studied, a place with rules of its own. A cosmic void is defined not by absolute emptiness, but by comparison. Compared to the average density of the universe, A void contains far less matter. Much less. If you could somehow measure everything inside this region, stars, gas, dust, dark matter, you would find only a small fraction of what you would expect elsewhere. Typically, voids contain less than 10% of the universe's average matter density. Some are even emptier than that. And yet, despite this scarcity, voids are enormous. You begin to sense their true scale as distances stretch in every direction. A single void can span tens of millions of light years. Many reach widths of hundreds of millions of light years. To put that gently into perspective, light, the fastest thing that exists, would need hundreds of millions of years just to cross one of these regions from side to side. This is one of the strangest truths about the universe. Its emptiest places are also its largest structures. As you float here, there are no sharp borders announcing where the void begins or ends. Instead, density fades gradually. Galaxies become fewer, then rarer still. Eventually, they almost disappear entirely. This gradual transition is part of what defines a void. It is not a carved-out hole, but a softly shaped region formed by the slow migration of matter away from it. Astronomers identify voids by mapping where galaxies are not. When large surveys chart millions of galaxies across the sky, patterns emerge. Dense filaments appear like glowing threads, while vast, dark regions open between them. These dark regions are the voids, not detected by what they contain, but by what they lack. And yet, lack does not mean nothing. Even now, as you hover in this calm expanse, there is still matter around you, just very little of it. A few faint galaxies may drift far apart, separated by distances so large they might never interact over the lifetime of the universe. These galaxies are often small and dim, their light weak and easily overlooked. They exist on the margins of cosmic society, quietly evolving in isolation. The defining feature of a void, then, is not emptiness, but isolation. Inside a void, gravitational interactions are rare. There are no nearby clusters pulling strongly on one another. No frequent mergers. No violent encounters shaping galaxies into new forms. Everything happens slowly here. Exceptionally slowly. A galaxy inside a void may live its entire existence without ever colliding with another. This is why voids are often described as pristine environments. They preserve conditions that are difficult to find elsewhere in the universe. Conditions closer to the original simplicity of cosmic evolution, before crowded neighborhoods and constant interactions took over. You might imagine a void as a cosmic countryside, far removed from the bustling cities of galaxy clusters. The distances between neighbors are vast. The pace of change is gentle. Time feels stretched. One of the criteria used to define a void is the absence of bright, massive galaxies. These galaxies, heavy with stars and dark matter, tend to live along filaments where gravity has drawn material together. Voids, by contrast, are dominated by darkness. Not dramatic darkness, but subtle absence. If a bright galaxy wanders too close, the region ceases to qualify as a void at all. This leads to an interesting paradox. Voids are identified by what they are missing, yet those missing things are precisely what usually help us understand the universe. Light, stars, structure. Without them, astronomers must rely on indirect methods, patient surveys, and careful statistical analysis to even confirm that these regions exist. As you continue drifting, the sense of scale becomes almost dreamlike. There is no obvious center to the void, no landmark to orient yourself by. Everything looks the same in every direction. An endless, gentle darkness punctuated only occasionally by a distant, faint glow. This uniformity is part of what makes voids so difficult to study and so fascinating to contemplate. It also challenges intuition. We're used to thinking of important places as busy places, crowded places, loud places, but the universe does not share that bias. Some of its most influential regions are defined by quiet and scarcity. The size of a void is often described in terms of diameter, but that number hardly captures the experience of being inside one. From within, the void feels infinite. Boundaries are too far away to sense. The surrounding filaments exist, but only as distant suggestions, like shorelines beyond a fog. And yet, those boundaries matter. They shape the flow of matter. They define how space expands locally. They influence how galaxies inside the void evolve over billions of years. Even emptiness, it seems, has consequences. As this realization settles, you begin to understand that a void is not simply an absence within the universe. It is a fundamental component of cosmic structure, vast, subtle, and quietly powerful. A place where the universe reveals itself not through abundance, but through restraint. And with that understanding, you drift onward, deeper into the low-density heart of the void, where scarcity itself becomes the defining presence. As you continue floating through this immense region, the word empty begins to feel less accurate. The darkness around you is not absolute. It is textured in subtle ways, layered with things that are simply too faint, too spread out, too quiet to announce themselves easily. This is where one of the most important truths about cosmic voids gently reveals itself. They are not completely empty. They are merely sparse, far apart, almost lost in the vastness. There may be a handful of galaxies drifting alone. These are not the bright, well-structured spirals you might imagine when thinking of galaxies. They are often small, dim, and underdeveloped. Dwarf galaxies, fragile and faint, carrying far fewer stars than their counterparts along the cosmic filaments. From a distance, their light barely registers. From here, they feel more like whispers than beacons. These galaxies exist in near total isolation. The nearest neighbor may be tens of millions of light years away. That distance is so great that gravitational interactions become rare, almost negligible. No close encounters disturb their shapes. No mergers force rapid change. As a result, these galaxies evolve slowly, quietly, following paths that are difficult to observe elsewhere in the universe. Even more elusive than these galaxies is the presence of dark matter. You cannot see it, cannot feel it directly, and yet it is here. Dark matter does not vanish inside voids. It simply thins out. Its density is far lower than in filaments or clusters, but it still weaves an invisible framework through the region. This faint scaffolding subtly influences how the few galaxies here move and evolve, even though its grip is gentle. Without dark matter, the universe as we know it would never have formed its large-scale structure. And even in places where matter is scarce, its influence remains. In the void, dark matter exists as a diffuse background, stretched thin by cosmic expansion and the migration of material toward denser regions. It is quieter here, but not absent. Then there is the gas. Between galaxies, filling the vast spaces you're drifting through, lies an extremely tenuous form of matter known as intergalactic gas. In voids, this gas is often composed mostly of hydrogen, warmed by ancient radiation and slow, subtle processes. Scientists refer to much of it as the warm, hot intergalactic medium, or WIM. It is not hot enough to glow brightly, not dense enough to shine, and not cold enough to collapse into stars. From where you float, this gas is invisible. It does not reflect light. It does not form clouds. It simply exists, spread so thin that entire galaxies could pass through it without noticing. And yet, taken together across the universe, this gas accounts for a significant fraction of ordinary matter. It is one of the reasons voids can never truly be called empty. There may also be solitary stars drifting through the darkness, rogue stars, untethered from any galaxy. These stars were likely ejected long ago, flung outward by gravitational interactions or violent events in denser regions. Over billions of years, they have wandered far from their origins, crossing filaments and eventually slipping into voids like this one. A rogue star here would be unimaginably lonely. The nearest source of light could be so distant that its glow barely distinguishes itself from the background. Around such a star, planets could exist, circling in near total cosmic isolation. The night sky, if there were eyes to see it, will be almost completely dark. This is what makes voids so strange. They contain matter, but that matter is disconnected, spread out, diluted to the point where interaction becomes the exception rather than the rule. From within this region, gravity feels different, not weaker in an absolute sense, but less complex. There are fewer overlapping gravitational fields, fewer competing influences. Motion here is smooth, slow, and predictable. Objects drift along gentle paths, guided by the faint pull of distant filaments rather than nearby neighbors. Because of this, voids act like time capsules. Processes that happen rapidly elsewhere unfold at a glacial pace here. Star formation slows. Chemical enrichment lags behind. Galaxies retain more of their original gas, less altered by interactions. In a way, voids preserve a simpler version of cosmic evolution. And yet, simplicity does not mean insignificance. Everything inside a void still participates in the universe's expansion. Space continues to stretch. Distances continue to grow. In fact, because there is so little mass here to slow expansion through gravity, space inside voids expands slightly faster than average. Over billions of years, this causes voids to grow larger, pushing matter even farther apart. As you drift, the sense of scale becomes almost hypnotic. You are surrounded by a realm where presence is defined by subtlety, where existence expresses itself not through brilliance, but through restraint. A place where matter has been thinned nearly to invisibility, yet never erased. This realization softens the meaning of emptiness. A void is not a hole in reality. It is a low-density environment, shaped by the same laws that govern stars and galaxies, simply operating under quieter conditions. And as you float onward, through gas you cannot see, past stars that glow alone, alongside galaxies that barely announce their presence, you begin to understand that even the universe's most silent regions are still alive with quiet complexity, waiting patiently to be noticed. Drifting deeper into this vast calm, you begin to sense that the void is not only defined by what it contains, but by how it behaves. The physical environment here follows the same universal laws as everywhere else: gravity, expansion, energy. Yet the outcomes feel subtly different. Everything is gentler, slower, more diffuse. The void has its own kind of physics, shaped by extreme scarcity. The most striking feature is the density, or rather, the lack of it. Matter is so spread out that encounters between particles are rare events. Atoms can travel enormous distances without ever colliding. Gas drifts in long, quiet paths, barely interacting, barely noticing anything around it. Pressure, which depends on particles pushing against one another, is almost non-existent. From a physical standpoint, this is one of the most relaxed environments in the universe. Because density is low, gravity is weak here, not absent, but uncompetitive. There are no massive clusters nearby exerting strong pulls. No dense regions warping space dramatically. Instead, gravity arrives as a distant suggestion, a faint tug from faraway filaments and walls. Objects respond slowly, gradually, over immense stretches of time. This weak gravitational influence allows something unusual to happen. Space inside the void expands slightly faster than the cosmic average. Elsewhere in the universe, matter's gravity resists expansion, pulling space back and on itself. But here, with so little mass to hold things together, expansion encounters less resistance. The void gently inflates, stretching distances even further. This effect is subtle. You would never notice it moment to moment, but over billions of years it matters. It causes voids to grow larger, pushing their boundaries outward and helping define the overall architecture of the cosmic web. In this way, emptiness becomes active, shaping the universe simply by offering less resistance. Temperature behaves differently here as well. The gas inside a void is often warmer than you might expect, despite its low density. This warmth is not the heat of stars or explosions, but a residual energy carried from the early universe and maintained by slow processes like shock heating and faint radiation. At the same time, the gas is so thin that it cannot cool efficiently. Heat lingers. Motion persists. From within the void, this creates an environment that feels oddly suspended between states. Not cold enough to collapse, not dense enough to ignite. Everything exists in a kind of extended pause. Radiation travels differently here too. With so little matter to absorb or scatter light, photons can pass through almost uninterrupted. Ancient radiation from the early universe drifts freely across these regions, barely altered by interactions. In this sense, voids act like transparent windows into the distant past, allowing information to travel vast distances with minimal interference. Time itself seems to stretch here, not physically, but experientially. Processes that depend on interaction slow to a crawl. Chemical reactions in gas clouds are rare. Star formation struggles to begin. Change happens, but at a pace so slow it almost feels timeless. As you float in this environment, the silence feels complete. Not the silence of absence, but the silence of balance. Forces exist, but they are evenly matched by expansion. Motion exists, but it is smooth and unhurried. Nothing rushes toward collapse or explosion. This is what makes voids so fascinating to scientists. They represent an extreme case, a test of physical laws under minimal conditions. How does gravity behave when matter is nearly gone? How does gas evolve when collisions are rare? How does cosmic expansion unfold when resistance is weak? Here, the universe answers those questions quietly. You can imagine the void as a vast, slow breath in the cosmos. Inhale where matter gathers into filaments. Exhale where space expands freely. The void is the exhale, long, gentle, and continuous. As this understanding settles in, you become aware that the calm around you is not emptiness, but equilibrium. A delicate balance between the forces that build structure and the expansion that pulls everything apart. And in that balance, the void finds its identity, not as a lack of physics, but as physics in its most subtle form. You continue drifting, carried by this gentle expansion, deeper into the stillness where the universe reveals how quietly it can exist. As you remain within this rarefied calm, your attention slowly returns to the few galaxies that manage to exist here at all. They are scattered widely, like isolated thoughts in an otherwise empty mind. These are the inhabitants of the void. Not many, not bright, but quietly remarkable. A galaxy born and raised inside a void lives a very different life from one in a crowded filament. There are no frequent encounters with neighbors, no tidal forces stretching its arms, no mergers that violently reshape its structure. Instead, it evolves in near solitude, influenced mostly by its own internal processes and the faint, distant pull of the cosmic web. Because of this isolation, void galaxies often retain large amounts of gas. In denser regions, galaxies lose gas through interactions, stripping, or repeated bursts of star formation. Here, that gas remains undisturbed, lingering for billions of years. Yet despite this abundance of raw material, star formation tends to proceed slowly. Without external triggers, collisions, or close passes, the conditions needed to ignite new generations of stars arise less often. The result is a population of galaxies that feel unevolved, almost frozen in an earlier cosmic era. Their stars are often younger on average, their structures simpler, their histories quieter. These galaxies offer a rare glimpse into how galaxies might develop in the absence of environmental pressure. Some of them are faint spirals, barely holding together. Others are small, irregular shapes, loosely bound and dim. Their light is soft, easily lost against the dark background of the void. From a distance, they might not even register as galaxies at all. One such example has drawn particular attention. A galaxy so isolated that it appears to exist almost alone in a vast region of space, separated from its nearest significant neighbor by tens of millions of light years. It drifts quietly, forming stars at a leisurely pace, unaffected by the drama that defines much of cosmic history. It is often described as the loneliest known galaxy, not because it lacks stars, but because it lacks company. From within the void, this isolation feels profound. If you could stand on a planet orbiting a star within such a galaxy, the night sky would be unsettlingly dark. Nearby galaxies would be rare sights, perhaps invisible without powerful instruments. The sense of being part of a larger universe would be faint, almost abstract. And yet, these galaxies are not failures of formation. They are not incomplete. They simply represent an alternate path, a version of galaxy evolution shaped by quiet rather than chaos. This is why astronomers value void galaxies so deeply. They act as natural control samples. By studying them, scientists can isolate the effects of environment from the intrinsic properties of galaxies themselves. What happens when a galaxy is left alone for billions of years? How much of its evolution is driven internally? And how much depends on interaction? Void galaxies help answer these questions. Their chemical makeup often reflects slower enrichment, with fewer cycles of star birth and death. Heavy elements accumulate more gradually. Their shapes remain less disturbed. Their histories are written in long, calm chapters rather than dramatic turning points. As you drift past one of these galaxies, its faint glow feels almost intimate, not because it is close, but because it is rare, a small island of structure in an ocean of emptiness. It exists not despite the void, but because of it, preserved by isolation, protected from disruption. In this environment, even time seems to behave differently. A billion years can pass without much change. A galaxy can quietly rotate, form a few stars, and remain largely the same across vast spans of cosmic history. This challenges the assumption that progress in the universe requires violence or interaction. Here, in the void, evolution is subtle. Growth is slow. Stability reigns. As you move onward, leaving this solitary galaxy behind, you carry with you the sense that the universe is not defined solely by its busiest regions. Some of its most revealing stories unfold in places where very little happens, where isolation allows simplicity to endure. And in that simplicity, the void's galaxies quietly remind you that even in the most spacious parts of the cosmos, life, in its stellar form, finds a way to persist. As you drift onward, the stillness of the void invites you to look backward in time, not in a dramatic way, but gently, as if the universe itself is recalling how this place came to be. Voids were not carved out suddenly. They were not emptied by force. They emerged slowly, naturally, as the universe unfolded according to its simplest rules. In the earliest moments after cosmic expansion began, matter was spread almost evenly everywhere. Almost, but not quite. Tiny fluctuations existed, faint ripples in density so small they would have been impossible to notice without extraordinary precision. Some regions contained slightly more matter than average, others slightly less. These differences were subtle, barely more than whispers. Gravity, patient and relentless, took notice. Over time, regions with a little extra matter began to pull in more. Their gravity strengthened. They grew denser, drawing material toward themselves. Regions that started out with slightly less matter lost even more, as their contents drifted away toward these growing concentrations. In this way, imbalance amplified itself. Density fed density. Emptiness fed emptiness. The void you are floating through began as one of those slightly underdense regions. At first, it was hardly distinguishable from its surroundings. But as billions of years passed, matter flowed outward, leaving behind a region increasingly sparse. This process did not require explosions or violence. It unfolded quietly, guided by gravity and expansion working together. As matter evacuated these regions, filaments and walls took shape around them. Galaxies formed along these dense structures, tracing out the cosmic web. Meanwhile, the voids expanded, growing larger and emptier with time. The universe organized itself naturally into this pattern, not by design, but by consequence. What's remarkable is how stable this structure becomes once established. Voids persist for billions of years. They evolve, yes, but slowly. Their boundaries sharpen as matter continues to migrate outward. Their interiors grow ever more rarefied. Over time, voids come to dominate the universe's volume, even as most matter becomes increasingly confined to thin structures. You can imagine the process like a slowly settling fluid. Denser material sinks into filaments and nodes. Lighter regions rise, expanding outward. The result is a cosmic landscape defined by contrast, where the emptiest places are framed by the densest. As you move through this void, you are witnessing the long-term outcome of that process. A region shaped not by catastrophe, but by patience. This evolution continues even now. Matter still drifts. Expansion still stretches space. Voids still grow. They push gently against the filaments that surround them, subtly influencing their shape and orientation. Over immense timescales, this ongoing interaction helps sculpt the universe's large-scale geometry. There is a quiet inevitability to it all. Once a void begins to form, it is likely to remain a void. There is little to pull matter back in. Without strong gravitational anchors nearby, the region stays empty, growing emptier as space expands. This is why voids are often described as some of the most pristine environments in the cosmos. They have experienced fewer disruptions, fewer interactions, fewer dramatic events. Their histories are simpler, cleaner, easier to trace back to the universe's earliest conditions. From a scientific perspective, this makes them invaluable. By studying voids, researchers can test models of cosmic evolution with fewer complicating factors. The physics here is less tangled. The signal's clearer, even if fainter. As you drift, you begin to sense how deep time operates differently here. Billions of years pass like slow breaths. Changes accumulate gently, almost imperceptibly. The void feels ancient, but not aged. It has grown, not worn down. In this quiet evolution, there is something profoundly calming. The universe did not rush to create this place. It allowed it to emerge naturally, as a consequence of simple rules applied over vast time. No drama, no urgency, just steady unfolding. And as you continue onward, carried by the slow expansion that helped create this emptiness in the first place, you find yourself moving through a region that embodies cosmic patience, a testament to how the universe builds its grandest structures through the quiet accumulation of small beginnings. As you drift deeper into the stillness, it becomes clear why places like this hold such quiet importance. The void is not just an absence of activity. It is a kind of natural laboratory, a place where the universe removes distractions and lets its most fundamental processes unfold without interference. Here, complexity falls away, and what remains is clarity. In crowded regions of the cosmos, everything influences everything else. Galaxies collide, merge, strip one another of gas, and trigger waves of star formation. Gravity overlaps and competes. Histories become tangled. Cause and effect blur together. Inside a void, by contrast, the universe simplifies itself. Fewer interactions mean fewer variables, and fewer variables make it easier to understand what truly drives cosmic evolution. This is why scientists are drawn to voids despite their faintness. They offer a rare chance to study galaxies that have grown up largely alone. When a galaxy evolves in isolation, its changes reflect mostly internal processes: the slow conversion of gas into stars, the gentle feedback from stellar winds, the gradual aging of its stellar population. External disturbances are minimal. The environment steps back and allows the galaxy to speak for itself. From within the void, this simplicity feels almost deliberate. You sense that nothing here is rushing to change. Galaxies rotate calmly. Gas drifts without urgency. The absence of frequent encounters allows long-term trends to emerge clearly, like faint patterns revealed only when noise is removed. Void regions also help scientists understand how environment shapes destiny. By comparing galaxies inside voids with those in dense filaments, researchers can see how much difference surroundings make. Why do some galaxies stop forming stars early, while others continue slowly for billions of years? How much of that story is written by location alone? The void provides one side of that comparison, a baseline of isolation. Beyond galaxies, voids offer insight into the behavior of matter itself. Gas in these regions exists under extreme conditions: low density, weak gravity, long time scales. Studying it helps refine models of how ordinary matter behaves when stripped of the usual pressures and interactions. It reveals how energy dissipates, how heat lingers, how matter resists collapse when left undisturbed. Even dark matter, invisible and elusive, behaves more cleanly here. In denser regions, its distribution is complex, shaped by mergers and clustering. Inside voids, its structure is smoother, more diffuse. This makes voids valuable testing grounds for theories about dark matter's nature and behavior. From a broader perspective, voids help anchor our understanding of the universe's overall structure. They are reference points, vast, stable regions against which change elsewhere can be measured. Without them, the cosmic web would lose its contrast, and the story of structure formation would be far harder to untangle. As you float in this quiet expanse, you begin to appreciate how much can be learned from places where very little seems to happen. The void teaches through restraint. It reveals by withholding. It shows that complexity is not always required for understanding. In this way, the emptiest regions of the universe become some of the most instructive. They strip reality down to its essentials and let the fundamental rules play out slowly, transparently, across billions of years. And as you continue drifting onward, you carry with you the sense that the void is not merely a gap between meaningful places. It is itself a place of meaning, offering clarity in a universe otherwise crowded with complexity. As you remain suspended in this vast openness, another truth begins to surface. Understanding a place like this is far from easy. The void may feel calm and simple from within, but to those trying to observe it from afar, it is one of the most challenging regions in the universe to study. Its very nature resists attention. It hides by being faint, diffuse, and almost indistinguishable from the background of space itself. The first challenge is visibility. Most of what exists inside a void does not shine. There are few bright galaxies to act as markers. Gas is spread so thin that it emits almost no light. Dark matter, which makes up much of the mass, cannot be seen directly at all. From Earth, these regions appear as vast, dark patches between brighter structures, not because nothing is there, but because nothing announces itself. To map a void, astronomers must first map everything else. They chart the positions of millions of galaxies, then look for the enormous gaps between them. Voids are defined statistically, not visually. They emerge only when enough data has been collected to reveal where matter consistently fails to appear. This requires patience, precision, and surveys that span huge portions of the sky. Even when a void is identified, probing its interior is difficult. The few galaxies that exist there are faint and distant, often requiring long observation times with sensitive instruments. Their light arrives weak and diluted, easily lost in noise. Each detection is careful, deliberate, and slow. Gas presents an even greater challenge. The diffuse hydrogen drifting through voids does not glow like the gas inside galaxies. To detect it, scientists must rely on indirect methods, subtle absorption signatures imprinted on the light of even more distant objects. This requires aligning observations across enormous distances, searching for tiny changes in light that reveal the presence of nearly invisible matter. Distance itself becomes a problem. In regions with many galaxies, relative distances can be measured and cross-checked. Inside a void, reference points are scarce. Determining how far away a faint object truly is becomes uncertain. Errors accumulate. Maps blur. The void resists being neatly outlined. There is also the challenge of scale. Voids are so large that studying them in full requires instruments capable of seeing both immense distances and minute details. A telescope sensitive enough to detect faint gas may have too narrow a field of view to capture the void's full extent. A wide survey may miss the faintest structures entirely. Balancing these needs is an ongoing struggle. As you drift through this region, you sense how easily it could be overlooked, how entire volumes of the universe could remain poorly understood simply because they do not shine brightly enough to demand attention. This invisibility is not accidental. It is the natural consequence of scarcity. And yet, despite these challenges, voids slowly yield their secrets. With each generation of instruments, with each deeper survey, faint traces emerge. Patterns sharpen. What once appeared as absolute emptiness reveals texture, structure, and subtle motion. There is something fitting about this difficulty. The void does not give itself up easily. It requires quiet observation, long exposure, and careful interpretation, much like the experience of drifting through it. Understanding comes slowly, piece by piece, never all at once. As you continue onward, wrapped in this dim expanse, you sense that the universe's most elusive regions demand the most patience. And in that patience, discovery waits, faint, distant, but enduring. As you float onward through this gently expanding emptiness, the void begins to reveal another layer of significance, one that reaches beyond galaxies, beyond structure, and into the deepest questions about why the universe expands the way it does. Here, in regions where gravity is weakest and matter is scarce, the universe quietly exposes hints about a force that shapes everything. Dark energy. Everywhere in the cosmos, space is expanding. Galaxies drift apart, distances stretch, and the universe grows larger with time. But this expansion is not perfectly uniform. In places crowded with matter, gravity slows the stretching of space. Clusters pull inward. Filaments resist being torn apart. Expansion there is held back, restrained by mass. Inside a void, that resistance fades. Here, there is very little matter to push back against expansion. Gravity whispers instead of commands. And so, space itself is allowed to stretch more freely. The void gently inflates, its interior expanding slightly faster than the cosmic average. This difference is subtle, but over billions of years, it becomes significant. From within the void, you feel this expansion not as motion, but as separation. Distances grow without effort. Objects drift apart not because they are moving, but because the space between them is quietly increasing. It is a slow, relentless process, unfolding beneath notice, shaping the universe without spectacle. This behavior makes voids uniquely valuable for studying dark energy. Dark energy is the name given to whatever is driving the universe's accelerated expansion. Its nature remains mysterious, but its effects are clear. And in environments where gravity offers minimal opposition, those effects are easier to isolate. By measuring how voids grow, change shape, and expand over time, scientists can test models of cosmic expansion. The way a void stretches, how quickly its interior expands relative to its boundaries, carries information about the underlying physics of the universe. It offers clues about how dark energy behaves across different environments. Voids, in this sense, act like sensitive instruments. They respond strongly to expansion because there is little mass to dampen the effect. Small differences in cosmic parameters can lead to noticeable changes in void size and shape. By comparing observations with simulations, researchers can rule out some theories and refine others. As you drift here, the emptiness feels purposeful, not passive, but responsive. The void expands not because it is empty, but because emptiness allows expansion to express itself more clearly. In denser regions, dark energy's influence is partially hidden behind gravity's pull. In a void, it stands exposed. This interplay between gravity and expansion gives the void a quiet dynamism. Its boundaries shift outward. Its interior becomes increasingly rarefied. Over time, voids come to dominate more and more of the universe's volume, even as matter becomes increasingly confined to thin filaments. There is a strange poetry in this. The future of the universe may belong not to its brightest regions, but to its emptiest ones. As expansion continues, voids grow larger, darker, more dominant. The universe becomes a place where isolation is the norm, and connection is increasingly rare. As you continue drifting through this region, you sense that the void is not just a leftover from cosmic evolution, but a window into its destiny. A place where the universe quietly reveals how it will continue to unfold, stretching, thinning, expanding, guided by forces we are only beginning to understand. And in that realization, the void feels less like an absence and more like a message, written not in light, but in space itself. As you drift onward, carried gently by the slow expansion of space, the void around you begins to feel less abstract. It becomes a place with identity, history, and scale, not just any emptiness, but specific regions that have been noticed, mapped, and quietly named. These are the great voids of the universe, vast hollows whose sheer size alone makes them impossible to ignore. One of the first such regions ever recognized lies far from the familiar glow of dense galaxy clusters. From the outside, it appears as a massive absence, a place where hundreds of thousands of galaxies seem to be missing. Its diameter stretches across hundreds of millions of light years, so wide that light itself would need longer than the entire history of complex life on Earth just to cross it. When astronomers first realized how empty this region was, it challenged expectations about how evenly matter should be distributed. From within, this void feels almost boundless. There is no clear edge, no sudden transition from emptiness to abundance. Instead, density fades slowly, like sound dissolving into silence. The surrounding filaments exist, but they are unimaginably distant, their influence faint and delayed. Here, the universe feels stripped down to its most minimal expression. Another vast region lies closer to familiar cosmic neighborhoods, yet remains just as quiet. Its proximity makes it easier to study, but no less mysterious. This void occupies a huge volume of space where galaxies thin dramatically, leaving behind only a handful of faint inhabitants. From here, the contrast is striking. On one side, dense structures rich with light. On the other, an expanse where darkness dominates. These famous voids were not discovered all at once. They revealed themselves gradually, as galaxy surveys grew larger and deeper. What first appeared as random gaps slowly resolved into coherent structures, enormous regions consistently lacking bright galaxies. Their scale forced scientists to confront an uncomfortable idea. Emptiness, not matter, might be the universe's most common state. As you float through one of these immense hollows, the feeling is not one of desolation, but of scale. Everything familiar shrinks in significance. Individual galaxies become rare events. Entire clusters feel like distant rumors. The universe's usual landmarks fade away, leaving only the quiet geometry of space itself. These voids also serve as anchors for cosmic mapping. By identifying their positions and sizes, scientists can better understand how the cosmic web is arranged. Voids define the negative space of the universe, the shapes that matter wraps around. Without them, the large-scale structure will be far harder to interpret. From inside, their influence feels subtle but persistent. They push gently outward, shaping the filaments that surround them. They help determine how matter flows, how structures grow, and how expansion unfolds. Their emptiness is not passive, it is formative. As you drift deeper into this vast region, you begin to understand why these voids hold such quiet importance. They are not anomalies or mistakes. They are natural outcomes of cosmic evolution, written into the universe's earliest conditions and refined over billions of years. Here, surrounded by one of the universe's great hollows, the cosmos feels older, calmer, and more patient. And as you continue onward, you carry with you the sense that even the largest names given to these voids barely hint at their true scale. Regions so immense that their silence speaks louder than light ever could. As you continue drifting through this immense quiet, it becomes easier to imagine what it might feel like to truly belong here. Not as a passing observer, but as a resident. Picture a planet orbiting a star inside one of these rare galaxies, deep within the heart of a cosmic void. From its surface, the universe would appear profoundly different from anything familiar. Night would fall gently, without competition from nearby lights. The sky would darken into an almost perfect black, not because clouds block the view, but because there is so little to see. The dense bands of distant galaxies that normally fill deep space images would be absent. No bright clusters would hang on the horizon. The universe would feel vast in a way that is difficult to describe. Not crowded vastness, but open vastness. Empty, yet endless. A few faint points of light might appear, where especially distant galaxies align just right. They would be subtle, barely distinguishable from the background, requiring patience and sensitive eyes to notice. Even with powerful instruments, the sky would seem sparse. The sense of isolation would be complete. The nearest large galaxy might be tens of millions of light years away, its glow too weak to register without careful observation. From such a vantage point, the idea of a structured universe might feel abstract. Without visible filaments or clusters, the cosmic web would not reveal itself easily. The observer might believe they live near the center of an enormous, empty cosmos, surrounded by darkness in every direction. Only through careful measurement, long exposure, and deep understanding would the larger structure become apparent. Time would feel different here, not because it flows differently, but because change is so slow. The sky would look the same night after night, century after century. No nearby supernovae would suddenly blaze into view. No close encounters between galaxies would rearrange the heavens. The universe would feel steady, almost unchanging. Yet this stillness would not be lifeless. The stars within the host galaxy would still rise and set. Planets would still orbit. Seasons would still pass. Life, if it existed, would unfold unaware of how alone it truly was. The void would not announce itself. It would simply be the background condition of existence. From this perspective, the universe might feel more intimate than vast. With so few distant landmarks, attention would naturally turn inward, toward the local star, the familiar planets, the immediate surroundings. The cosmos beyond would feel remote, quiet, almost irrelevant. And yet, hidden within that darkness would be the same grand structure that exists everywhere else. The same laws, the same expansion, the same slow evolution. The void would not be a special exception, just an extreme expression of a universal pattern. As you imagine standing beneath such a sky, the quiet feels complete. The absence of distant light does not feel threatening. It feels calm, reassuring, a reminder that the universe does not need spectacle to exist meaningfully. As you drift away from this imagined world, leaving its dark skies behind, you carry with you the sense that perspective shapes experience, that the universe can feel crowded or empty depending on where you stand. And that somewhere, deep within a cosmic void, the night sky is almost entirely dark and perfectly still. As you drift onward, the silence of the void begins to feel less like an absence and more like a framework. You start to sense how these vast, empty regions are not merely spaces between things, but essential components of the universe's overall design. Without voids, the cosmos would lose its shape. Its architecture would blur. Structure itself would become harder to define. The universe, on its largest scales, is not built only from matter. It is built from contrast. Dense regions exist because less dense regions surround them. Filaments stand out because voids press gently against their edges. The cosmic web is as much about where matter is not as where it is. In this way, voids act like the negative space in a work of art, invisible at first glance, yet crucial to the form as a whole. As you float here, it becomes clear that voids help organize the universe by guiding the flow of matter. Gravity pulls material toward filaments and clusters, but it is the expanding emptiness of voids that helps direct that movement. Matter drains away from underdense regions and collects along their boundaries, sharpening the web-like pattern over time. The universe sculpts itself through this slow exchange between fullness and emptiness. Voids also define scale. They set the distances between the universe's busiest regions. They determine how far filaments stretch, how wide walls grow, how isolated clusters become. Without voids, everything would be closer together, more tangled, harder to separate conceptually. The clarity of cosmic structure depends on these great expanses of near-nothingness. From within the void, this role feels subtle but persistent. You are not at the center of attention, yet everything around you is shaped in relation to this space. Filaments curve around voids. Clusters sit at their intersections. The void quietly dictates where structure can and cannot form. There's also a temporal role. Voids preserve the memory of the universe's early conditions. Because they experience fewer interactions and disturbances, their large-scale properties change slowly. They retain imprints of initial density fluctuations, offering clues about the universe's beginnings. In this sense, voids act as long-term records, not written in stars, but in absence. As you continue drifting, you realize that voids help maintain balance. They prevent matter from collapsing entirely into dense knots. They provide room for expansion. They ensure that the universe remains dynamic rather than static, structured rather than uniform. Emptiness, here, is a stabilizing force. This perspective shifts how you think about importance. The brightest regions of the universe draw attention, but the emptiest regions quietly hold everything in place. They give structure its boundaries. They give motion its direction. They give the universe its large-scale coherence. As you move deeper into this understanding, the void feels less like a background and more like a foundation, a vast, quiet scaffold supporting the visible cosmos. And in that role, it becomes clear that the universe is not built in spite of emptiness, but because of it. As you drift onward through this immense stillness, your thoughts begin to turn gently toward what lies ahead, not just for you, but for those who continue to study places like this. The void, quiet and elusive, has not revealed all its secrets. In many ways, it has only begun to speak, and the future of understanding it rests in patience, sensitivity, and tools designed to listen rather than force answers. Studying a region so faint demands instruments of extraordinary subtlety. The next generations of observatories are being shaped with this exact challenge in mind. Their purpose is not merely to look farther, but to see more gently, to detect the weakest signals, the softest traces of matter drifting through space. In doing so, they will begin to fill in the outlines of what has long remained invisible. From these future perspectives, voids will no longer appear as blank regions between galaxies, but as environments with measurable structure. Faint gas will be mapped more precisely. Tiny galaxies, once lost in darkness, will emerge as quiet points of light. Patterns within the emptiness will begin to resolve, revealing how matter truly behaves when stripped of crowding and collision. These observations will allow scientists to test and refine simulations of cosmic evolution. Computer models can already recreate vast cosmic webs filled with filaments and voids, but real data is needed to confirm the details. How smooth are void interiors? Really? How sharply defined are their boundaries? Do they grow exactly as current theories predict, or do they carry subtle surprises? Future research will also deepen the search for the faintest galaxies that reside in these regions. Each discovery adds a piece to the puzzle of how galaxies form under extreme isolation. By cataloging these dim inhabitants, researchers can better understand the minimum conditions required for star formation and how long such processes can persist without interruption. There is also the promise of improved measurements of cosmic expansion. As observational techniques advance, voids may become powerful tools for probing the universe's large-scale behavior. Their shapes, sizes, and growth rates offer sensitive tests of cosmological models. Even small deviations from expectation could hint at new physics, quietly hidden within the emptiest spaces. As you float here, imagining these future efforts, the void feels patient. It has existed for billions of years. It can wait a little longer. Its secrets are not fleeting. They unfold slowly, revealing themselves only to those willing to observe with care and restraint. In this sense, the future of void research mirrors the void itself. It favors subtlety over spectacle, precision over urgency, listening over shouting. Understanding will come not from dramatic breakthroughs, but from steady accumulation. Faint signals added together over time until a clearer picture emerges. As you continue drifting, you sense that the universe is not finished telling its story, and that even in its quietest regions, there are chapters yet to be read, written softly, in darkness, waiting for eyes patient enough to notice. As you drift onward, the journey through this immense emptiness begins to feel complete, not because there is nothing left to explore, but because the void has slowly revealed its nature. What once seemed like an absence has taken on form, behavior, and quiet purpose. You now sense that this place is not a flaw in the universe, not a gap where meaning ran out, but a fundamental expression of how the cosmos organizes itself. The void is not a perfect vacuum. It is not nothing. It is a region where matter exists at its lowest density, where interactions are rare, and where time stretches gently across vast distances. Within it, faint galaxies persist, gas drifts unseen, dark matter weaves an almost imperceptible framework, and space itself expands with minimal resistance. Everything here follows the same laws as elsewhere, simply under calmer conditions. In understanding this, the idea of emptiness begins to soften. The universe does not divide neatly into places that matter and places that do not. Even its quietest regions play essential roles. Voids shape the cosmic web. They guide the flow of matter. They preserve traces of a universe's earliest moments. They offer clarity where complexity elsewhere obscures cause and effect. From within the void, the universe feels balanced, not dominated by light or violence, but held in equilibrium between gravity and expansion. The cosmic story is not told only through collisions and brilliance, but through patience and restraint. Growth happens here too, slowly, subtly, over unimaginable spans of time. As you float in this final understanding, the void no longer feels empty. It feels intentional, a reminder that space itself is an active participant in the universe's evolution, that what is missing can be just as important as what is present. The universe, it seems, is not built solely from stars and galaxies, but from the spaces between them. And in those spaces, meaning persists, quiet, expansive, and endlessly patient. Now, as the journey gently comes to rest, allow the images to soften. The vast distances blur. The faint galaxies fade back into darkness. The cosmic web loosens its shape and dissolves into a calm, open quiet. You are no longer drifting forward. You are simply floating, suspended in a universe that does not demand attention, does not rush, does not insist on answers. The void surrounds you, not as emptiness, but as space to breathe. There is nothing you need to hold on to now. No structures to map, no mysteries to solve. The universe continues its slow expansion without your effort. Galaxies drift, space stretches, time unfolds gently, whether watched or not. Let the stillness settle in your body. Let your thoughts thin out like matter in a void, becoming lighter, quieter, more distant. Each breath feels unhurried. Each moment stretches softly into the next. In this calm, you are allowed to rest. The universe does not need your vigilance. It carries on, patient and steady, holding even its emptiest places with care. And as the last traces of light fade from view, you remain, relaxed, unburdened, gently drifting towards sleep, wrapped in the quiet architecture of the cosmos.